possibly Tuesday on this, but I will mix it up with word problems. Okay, so don't be too afraid of it. You just have to follow along. Okay? So have your calculators ready to go because I'm gonna draw from it. I know if you be so kind to turn off the lights there. Part 3. So last booklet, there's another one coming. Unless the money is so good that the demand is so great that I'll make another one. I was actually very happy that it arrived because I just finished it yesterday and I emailed the print service, can I have it for tomorrow? And they did, but they delivered it at TechVoc. So somebody still grabbed it and delivered it at Sisler, so I'm happy about that. So part 3, ambiguous case, here we go. A highlighter as well, okay? The ambiguous case of the sine law. Remember, I'm saying it's sine law, so cosine law doesn't have an issue. It's only sine law that has a problem, okay? So the ambiguous case of the sine law, right? Maybe all of it, but only an issue when dealing with SSA cases. That is very important. Side angle. You remember the trick? How do you know? Obviously, a diagram you know, but the trick is if you have like, let's say it's triangle XYZ, right? And I give you angle X is this, right? Side X and side Y, let's say. As you see the angle X and the side X, this is a pair, and there's another side, so you know this is SSA. Okay? So you can just tell by the letters and the way it's presented, and I'll show you that as we go along. As mentioned earlier in this unit, cosine of an obtuse angle results in a, you have to fill this in, negative ratio, right? If you take the cosine of an obtuse angle, you get a negative. So cosine of 100, you just quickly run this through. You don't have to do it. Just make sure you copy everything else. This is negative 0.1736. And that keeps going, but emphasis on the negative. Applying the inverse of cosine of a negative ratio will result in an obtuse angle. So this is technically just review, right? So if I were to take the inverse of cosine of a negative value, you, without hitting enter, you know it's going to be greater than 90. I hope at least at this point you know that. If not, this is a reminder, right? So obtuse greater than 90. What about sine? Let's explore this. We omit tangent since we're not using tangent. Technically, you can insert tangent here, but it behaves, I will just say, behaves just like cosine. Okay, tangent behaves just like cosine. So let's hope that cosine behaves well, right? So there we go. Tough crowd today. Anyways, let's fill in this chart real quick. There's a pattern. There's a couple patterns I want you to figure out. So I'm just going to run through it. Maybe you just write it down. So this is 0.3420. Sine of 50 is 0.7660. Sine of 75 is 0.9659. 0.9659. Okay. Let's do the same thing for cosine. So I'm going to cosine 20. That's 0.9397 rounded. Cosine of 50. So just write this down. You don't need to worry about actually, because I know you know how to do this. Right? So cosine of, it's the pattern that I want you to focus on. Okay, so you've got those values filled in there. You've got those down. That's easy, just close, right? And then this This is a way of saying the supplement. Right? 180 degrees minus theta, right? Theta are these angles here. So the supplement, which is written as 180 minus theta, the supplement of this would be 160 degrees, correct? The supplement of this one would be 130 degrees. And the supplement of 75 degrees would be 105. Okay, so I'm basically just taking theta and subtracting it to get my supplement. So these two angles, the pairs here, they're supplementary. So let's see what happens here. Let's take, follow along, let's take sine of 160. Sine, this is when I'm going to slow down a little bit. Sine of 160. What do you get? 0.3420. Do you notice something here? It's the exact same value. Everything is exactly the same. So sine did not make a distinction between the two. What about cosine of 160? Cosine, where are you, cosine there, of 160? It's negative, big emphasis on that, 9397. So what has changed from cosine of theta, which is 20, and cosine of its supplement? The value is exactly the same, but the sign is different. I need you to be able to predict that. So what do I mean? Next time, if I said, hey, if cosine of 20 is this, you should be able to predict that cosine of its supplement is exactly the same thing, but with a negative in front of it, because it's obtuse. So let's keep going. How about you trust me at this point? The sine values are going to be exactly the same every single time. What would happen there? What happened there? The sine values are going to be exactly the same every single time. However, the cosine values, all I'm going to do is throw a negative in front of it. Two reasons. I know that it's an obtuse angle, but I've observed before that I got the exact same value. So I can just use my previous answers to predict what the cosine ratios are going to be. Okay, so maybe, just maybe, I will emphasize the negatives, right? And that cosine distinguishes, cosine knows, oh, 160, it's going to be a negative, right? It's an obtuse angle, negative, obtuse angle, negative, obtuse angle, negative. If it's an acute, let's put that here. These are all acute, and these are all obtuse. Okay, that's why I left room around it, because I usually fill in. Acute, all positives, right? For acute, we had positive, positive. For obtuse, we had positive, like they're all positive, but we had negative for cosine. So that's something moving forward. So with cosine, it knows the difference. Some observations here. All three trig functions return a positive value for acute angles. All three functions have the same numeric value for an angle and its supplement. The numeric value is the same thing for it and its supplement. It's the exact same number. That's also important to remember. Can you see all right? Yeah. Only, oh boy, I did this yesterday without, oh yeah, here. Only cosine and tangent, even though we didn't explore tangent, right? Cosine and tangent return a negative value for obtuse angles. angles. Sine will have the exact same value and sign for acute and obtuse. Okay, I will highlight that whole thing because that's what causes the issue with sine. That is where everything hinges around that. That is the problem with sine law. Sine does not distinguish between acute and obtuse. It will always return an acute angle. That's also sine. You can do this. Sine will always return an acute angle. That is a problem. Cosine and tangent will give the numeric value. However, it will be a positive ratio for acute angles and a negative ratio for obtuse angles. So I'm repeating some of the things I know, but I'm just really emphasizing that. So in general, we can conclude the following. That sine of theta is going to be exactly the same as sine of 180 degrees minus theta. And you're like, that almost looks like standard deviation. What is standard deviation doing in trig, right? It's theta. Okay. I'm not an expert in Greek, so that's as best you can get. Cosine of theta is not going to be exactly the same. It's going to be exactly the same as the negative of cosine of 180 degrees minus theta. Tangent is going to be equal to the negative of tangent 180 minus theta. And remember, this is just a fancy way of saying it's supplement. It's supplement. So you couldn't say, hey, cosine of theta is exactly the same as cosine of the supplement. You can't say that because this one will be negative. That's why we need to plot that little negative in front of this expression, because negative and negative will turn positive. Right? And I have a bunch of questions that will make you think through this to put this into practice. Okay. Next page. I won't do every single example that's on here. It's just I just put so many examples on there so that if I need it more, I can, or I can assign some to you. But a lot of this will be left blank, and it's not because I'm skipping, it's just because I have more examples than what I need. Okay. Calculate the measure of angle A using sine law and cosine law. Watch this. Diagram is drawn to scale. Why do I mention that? Yeah. So you can tell, you know, based on this, that A is obtuse, right? You know without a doubt that this guy right here is obtuse. Yeah, we know that. So let's, what do you want to use first? Let's go cosine law first. So I gave you lots of information. So cosine law, do you remember how to use it? I hope so, right? Cosine of A is equal to, I put that one down first, 12.551 squared. Why would you use 3 decimals? Just because I want it to be as accurate as possible. So I go minus the side that's across, that it goes first, and then it's 2 times 6.168 times 7.82. And this gives me flashbacks to COVID, the first wave, because that is what I taught the very first time we went on remote learning. My dungy basement. Anyways, I'm going to do that underneath here. Cosine of A is, and I made changes to my original, so I'm just going to have to do this with you. So bear with me. So the top is negative 58.330977. And the bottom is this. And I'm going to go cosine inverse. I'm going to just do this in one shot, okay? Cosine like that. I'm going to go negative 58.330977 divided by 96.46752. And it's supposed to be 127.21. Okay? So I'm going to write down that I used all of this, right, like that, 96.46, and so my angle ends up being 127.21 degrees. Beautiful, right? We expected it to be obtuse, cosine delivered, and there you go. Now let's use sine law. And here's the problem. Here you're going to see it firsthand. Okay? You always thought sine was your friend. Well, you can't always trust sine. Okay? So what am I going to use? I see a pair here. I gave you a little bit too much information, right? So I did that for a reason so that we could use sine law. So let's go ahead. Sine of 23.049 degrees. I know it's hard to see, but that's what it says there. Over 6.168 is equal to sine of A over 12.551. So then sine of A will be cross multiplied there. Divided by 6.168. Sine of A. This one I will figure out the decimal for just because. .168, and that is 0.7941, and that keeps going. So angle A is sine inverse of 7941. Angle A is 52.57. Yay, right? And what's the problem? We clearly know it's not acute, right? It's supposed to be 127. So what just happened here, guys? What just happened? Well, first of all, sine doesn't know the difference. You know which angle sine found? Sine found this one right here. Make a dashed line. Because this obtuse angle has its acute angle right next to it. Its supplement, this one here. That is the one. If you have a different highlighter, that is the one you just found. You found orange. You found 52.57 right here. 52.57. And you don't want that. You want the inside, right? So what do you have to do here? So I will say, but A is obtuse, right? Therefore, how would I find A? I'll just go 180 minus 52.57. So 180 minus answer, there we go, 127.43. And you're like, it's not exactly the same. I know. We would have to use more decimals for that to happen, right? And this is what we wanted. We wanted this one. So what is this for? Why did I just do all of this? If I give you a triangle and I tell you it's obtuse, when you get, I will probably do it in such a way that you can only use sine law to solve it. So then you just have to take that extra step, right? Take that away from 180, and then you're done. Okay. So there's that experiment there, right in front of your eyes. Now you know. Okay. I don't know if you want to split this here. Cosine, sine, right? Obviously, with cosine law, don't worry about it. In fact, you will never have to worry about it, right? Unless it's an obtuse, in this case. Let's do another, I will just do a couple. I won't do all of these, okay? State of the following statements are true. So boxed in thing is maybe on your study sheet, right? Check for, are angles supplementary? Do they add up to 180, right? Does the equation have opposite signs or do they have the same sign, right? Opposite sign, it would have to be cosine or tan. Same sign, you're talking sine. Okay. For cosine and tan, the signs need to be opposite on the equation. For sine, they have to be exactly the same. So let's do this first one. Is this true or false? You check the angles. Are they supplementary? You bet. So that's the first test. And then it's cosine. What should the signs be if it's cosine? Let's check. For cosine, it would have to be opposite. One of these would have to be negative. So same sign, right? Cosine needs opposite signs. Therefore, false. You don't need to do all of this on a question. Like it should take you seconds to do this on a test. Okay. Next one, sine. Let's check if the angles are supplementary. They do not add up to 180. And then it's false. They don't even bother checking for sine. Don't even bother checking for sine. Here, check real quick. This is 180. So we got to continue our journey. Sine, so same signs. And sine does need both sides to be the same. So check, true. This statement is true. Stop. Stop. What are we doing here? If you, let's say you're like, you don't get this part. Just do this for yourselves. Sine of 80, let's clear my screen here. Sine of 80 is 0.984, blah, 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 right? Sine of 120 sorry, it's Friday. I know, it's false. Sorry, guys. Anyways, so, okay, my bad, guys. Just erase. Forget that this ever happened. This is false right away. What is Mr. Dirksen doing, right? My bad. We should have stopped. And see my calculator thing proved it, right? I was like, wait a minute, like they're not the same at all, right? So one way or the other, figure out if it's right. Anyways, let's keep going. Maybe I'll get it right now. 180, check, right? Opposite signs, which is what we want, check. This is true. This is true. And if you type in cosine of 120, you would get a negative value. If you type in cosine of 60, it's actually positive, but the negative in front of it makes it negative, right? So this would actually be true. Both sides would be equal to each other. I'm gonna move on. I don't want to spend too much time on this. I might get another one wrong and throw you off, right? So that will be on the homework. Stuff like that will be on the homework. Calculate the following to 4 decimals, then predict. This I will expect you to know this one. So we'll just do a couple. So sine of 73 is 0.9563, right? What would the supplement be? Hey, I know it's going to be exactly the same, Mr. Jerkson. I know that. Sine, the whatever angle and its supplement, they're going to be exactly the same. Cosine of 118. We know I'm going to get a negative here. I write that down. That I calculate. 4, 6, 9, and that keeps going. So its supplement will be an acute angle, right? Its supplement will be 0.469 ... positive. So if you want to emphasize the fact that it's going to be positive, then it's fine. But we know that its supplement is going to be a different sign. Tangent of 12 is 0.212, and that keeps going. What will be its supplement? It behaves just like cosine, so 0.212. Right? Because this is essentially tan of 168. And we'll just leave it at that. Continue here. State all possible values for the following. Why is it saying that? State all possible values. And in the textbook, we'll do this. All possible values between 0, theta, and 180. So it's just saying between 0 and 180, give me all possible angles that pertain to this situation. So watch this carefully. What you do here is to find theta, you got to go sine inverse of 0.4327. Correct? You're with me? So I'm going to go inverse sine of 0.4327, and that's 25.64. Could it be that there's also an obtuse angle though? Possible? The answer is yes. Sine doesn't know the difference. So you got to go, the next one is 180 minus 25.64. So when it comes to sine, you know it's going to be two different answers, 154.36. So this and this, right? It could be two possible answers. And the reason being is, right, you can always imagine sine will by default give you the smaller acute angle every time. But there could also be, we could also be referring to this. So you've got that, and you've got that one. You only worry about this with sine. Cosine, for example, to find theta here, it's cosine inverse of 0.675. That's 47.55 degrees. We knew that because this is a positive right there, right? Which is acute, which is what we got there. Done. Cosine is either acute or obtuse. It knows. Yeah. Go ahead. Let's do one more here. Theta is cosine inverse of negative 0.589. You know without a shadow of a doubt that this is going to be an obtuse angle. What's happening there? Is it 330? There. 126.09. We knew that. Cosine, no worries. Don't worry about it. For this one, it's sine, right? Sine has two possible answers. Sorry, I promise you it says answers there. And you're like, Mr. Dirksen, why didn't we talk about this before? Because I made sure every single time it worked out. I made sure every triangle you saw, you would not run into this issue. Okay. And so now we're talking about it. Because if I talked about this right away, you would have been struggling because it's too much to handle right off the bat. Okay. So 76.86 is the angle degrees, or theta could be 180 minus my answer, which is 103.14. So it could be this one that we're referring to, or that one. There's only two, by the way. There isn't more than two, okay? It's either the acute or the obtuse. That's it. And together, they add up to 180 degrees every single time. Let me just check what's on the next page here. Okay. We'll do this and then we'll skip a couple pages. So let's say you get a chart like this and you're given sine of theta as this. Will the resulting angle be acute, obtuse, or both? And in this case, it's both. When it's sine, I'm going to highlight all the signs. Okay, sine, sine, that's it. And then I will highlight both. So if you scan your list for wherever there's a sine, you've got two options. But the other ones you need to figure out based on the sign. Cosine of a positive, cosine, right? If you have cosine of theta is positive, that will be acute. Next, cosine of a negative, it's negative, right? Obtuse. Because cosine knows the difference. Tangent behaves just like cosine. So tangent theta, if that equals to a negative value, you know it's obtuse. Cosine of a positive, right? That's acute. So no need to do anything there. I'm going to highlight the negatives and just tell me that the negatives at the very least should tell you it's obtuse. And then we want the value of theta, so we're going to do that. Theta is sine inverse of 0.6648. Actually, maybe you should follow along, right? You never know. Or I'm just going to go 180 minus answer. That's 138.33. Okay. And I'm going to go here, cosine inverse. I wish I could just fast forward this part to where I really want to go. But I think you need a few of these. So just copy for now. This is 9.03 degrees. We expected it to be acute. We got an acute angle. Cosine inverse of negative 0.3326. 109. I need your texting skills to be a little bit faster. Right? Sine inverse 0.1239. So that's 711, no, 712, sorry. Or 180 minus that, that's 172.88. And inverse tan, I've thrown a tan here and there because who doesn't mind a tan, right? I'm just kidding. Tan negative 0.5, it behaves, that's a problem. It's an obtuse angle. It gives you a negative answer. And if you have a negative answer, you need to take that away from 180. Don't worry about that. Which is 153.43. I'm never going to do that. I'm not going to do that to you. So just make an arrow. Don't say equals, but that's 153.43. If ever in life you end up with a negative angle, you need to subtract that from 180 to get the actual. And this one, just trust me, I'm just going to give you the answer to that one. 32.35 degrees, okay? So it's the both that you need to watch out for when it's sine, okay? We're going to skip a bunch of pages. This is what I really wanted to get to, this part that's coming up. So we're going to skip to page 35. As I said, I just have more than I need, just in case. So this is a flow chart. And this flow chart you're gonna have to make a mini version of this for your study sheet. Okay. Applying the ambiguous case of the sine law, and this is specifically, I will ask you to highlight, determine the number of solutions. When given a non-right triangle, which is basically oblique, and you determine that it's the SSA case, you need to take extra precautions moving forward, especially if there's no diagram provided. I will just underline that, especially if there's no diagram provided. SSA. So we're going to talk about acute first, when the given angle is acute, because that is the more challenging one. The obtuse is actually fairly straightforward. Can I just say, remind you, we do not need to worry about this with any other cases. So SSS, SAS, those are cosine law, forget about it. If you're given two angles on a side, don't worry about it. Okay, this is only SSA. You want to force your diagram to look like this every time. And there's going to be, this is going to be the side that you're given, another side that you're given, and the angle across the one side is also going to be given. So you're given three things, right? The best thing that I can come up with is the rod and a string if you're fishing, right? This is your fishing rod, and this is your string, right, with a hook on it, right? So think of it that way. And why is there a string? Well, this is actually, we don't know at first if you're going to be able to make a triangle with the information you're given. And here's a visual on my iPad. Watch closely. This is what I want you to think of. So you're given this side and that side and a particular angle. The dashed line is unknown to us. Pretend like that's the floor, like you're standing on with your rod and your fishing line, and you're going to see, is that line long enough to even make a triangle? right? So in this case, you can clearly tell that the line is not long enough, correct? You would not be making a triangle there. When do you think you're gonna, when do you think you can make a triangle? When this dangling line is touching the bottom, right? What would that be from the top to the bottom here? What would we call that? The height of the triangle, right? So let's extend that. This is side A. I'm going to extend that. Oh, how do you find the height of the triangle? 9 times sine of 38, right? Can you quickly do that? Just have that on your calculator. 9 times sine of 38. I will do that too. 5.54, right? So I need this side to be 5.54. Let's see how well I'm going to be able to. Oh, I guess it doesn't let me to go 5.54 exactly. Can I type it in manually? Anyways, if it had been exactly 5.54, like at this point, technically it should be touching and creating. Let's see if I can stop it from moving. No, can't. Oh yeah, pause right here. There. There, right about there, at that length, you'll be able to make one triangle. But then there will be cases where that side is actually longer, right? That the string is going to be longer, so you'll be able to make a small triangle here. Or if you were to swing past the ground over to the other side, you make a big triangle here. Okay, so we're going to have to determine how many triangles. Is there even one possible? Like sometimes you don't have one. And I will guide you through it step by step. Okay, so let's talk about it. So you will draw your diagram. This is step one. Always step one. This is step two, which is very crucial. Right? Guys, everything revolves around the string. Okay? Is the string greater than or equal to the rod? You ask yourself that question, right? If the answer is yes, if the answer to this question is yes, boom, one solution, you're done. One solution or one triangle, it's the same thing. We're talking about the same thing. So you're done. You don't have to worry about it. This is what I always ensured was the case. For all the triangles you got, I made sure the string was longer than the rod. I will make a note here. If the string is equal to the rod, what kind of triangle would you have? If this and this is exactly the same, not equilateral, isosceles. Right? But you still have one solution, regardless, right? It's one solution, boom, you're done. However, if the answer is no, then you have to find the height. And the height is, in this particular case, b times sine of x. Okay? And then you'll have a number on your calculator or on your paper. Okay? And now ask yourselves, if the string, again, everything revolves around the string. If the string is shorter than the height, what do you think is going to happen? Can we just go up here and just draw our height? This is the height h, right? If the string is shorter than the height, what do you think is going to happen? Can you make a triangle? It's just going to swing, right? It's not going to close it. So if that happens, you have 0, no solution. No triangle possible. And you can literally just imagine this thing just swinging back and forth. It's not going to close it. And then the next one is when the string is exactly equal to the height. How many triangles do you think you'll have there? One, uno, right? One solution. But this is going to be a special one. What kind of a triangle do you have? So no solution here. One solution here. This is a right triangle in particular. You have a right triangle when that is the case. And then what if the string is greater than the height? That, ladies and gentlemen, is when you have two solutions. That is the one that is going to take a lot of our time solving, because you literally have two triangles to solve. And this is what they look like. One of them looks like this, okay? Like that's when the line swings to the left and hits the bottom here. And the other triangle looks like this. Emphasis on that dot there, right? You have your two solutions. And this is your justification for every single one of them. I don't mind you using string and rod and height. So for this one right here, you just say that the string, at the very beginning, the string was shorter than the rod. That was our very first question we asked. And the string is also shorter than the height. So this is the justification. For this one, every single one of these, actually, let's do that first. For every single one of these, we had to determine that the string was shorter than the rod. All of them. That's why we are in this category, right? And then in this case, the string is exactly equal to the height. And in this case, the string is actually greater than the height. Make sure you have this down, okay? And I know right now it's overwhelming, but trust me, I'll walk you through it. If I could do it online, remote learning, I'm pretty sure I can do it while you're here. Okay? So that was a tough task at first. Okay. So let's walk through this. What's happening here? Well, first of all, you determine that the triangle, the information indicates that this is SSA. Okay, if it's SSA, I need to watch out. I'm going to draw my diagram like this, and I put the side and the angle, that the pair, I put them like this. I make sure that the angle that they're giving me is always here, right? And the other side that they're giving you, just make sure it goes there. And then you ask yourself, is the string, if the string is bigger than the rod, right? If the string is bigger than or equal to the rod, boom, one solution. You don't need to even worry about this bottom part. Don't worry about it. But if it happens that the string is not larger than the rod, right? If it's less than, then you need to find the height, and you need to compare the string up here to the height. You need to do that. You need to compare it. So only one of these branches is going to be possible. You can't have, oh, it's both here. No, it's either that the string is shorter, you can't have a triangle. The string is exactly the same as the height, one possible solution, which is a right triangle, or two solutions when the string is greater than the height. So notice that down here, the rod doesn't come into play anymore. That's already done. You dealt with that. It's all string and height, okay, to determine how many possible solutions there are. All right. Go to the back side, the right next to it, it's this one. What if it's an SSA and it's obtuse? You force your diagram to look like this. Notice at the bottom, I kind of tend to make it dash, right? So you're given this angle and you know it's obtuse. It's going to be bigger than 90. You put the side opposite to it there, and the rod goes here. So this is when you actually caught a big one, right? You got to pull back, right? And so there's only two options here. String is shorter than rod, no solution. Done. If the string is greater than the rod, one solution. Done. Right? No, you're like, what about the height, Mr. Erickson? Don't worry about it. Obtuse. If this is obtuse, don't worry about it. One solution or no solution. That's where we're at. Okay, so if you want to do this and this, you're done. What did I want to say here? There was something. I think we're good. I do say here, no need to find the height, right? Maybe remind yourself, no need to find the height. You can, but it doesn't matter. Like even if you found the height, it's not gonna help you out. By the way, this is my promise to you. When it comes to this, the question will say, how many solutions are possible? Like most of the time, there'll be sine law, cosine law, you're solving away. You usually don't have to worry about that. The only time you should be aware of this is like, how many solutions are possible? Or if I tell you this thing is drawn to scale and the angle is obtuse, right? Or it's an obtuse triangle, then that should be like ding, 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 right? Something else is happening here. Sine law is giving me an issue, right? I will get you straight to page 38. In each case, determine if it's SSA, right? If so, how many solutions are possible? This is the kind of question you're expecting. If it's a word problem, I would ask you, hey, is there more than one solution? You're like, okay, this is the ambiguous case of the sine law. So follow me here. Triangle ABC has angle A, side A, and another side. So two sides. Is this SSA or could it be that it's SAS, right? Well, you have the side, but this tells you that it's SSA. Okay, we know it's SSA. because I'm given two sides and one of them is across the angle. So boom, it's SSA. So justify. We need to justify now. Okay. And this is the process of you justifying. You make one of these. Dun, 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 right? And then you go up and don't close it. Just have it like that. And the angle you're given is angle A. I make it be over here. Okay? And that is 37. And side A obviously is going to be across angle A. So this is 228.3 feet. And the other side, it doesn't matter what it is, the other side, you're going to make it be here. That is your rod. Capiche? Right? So as I say, oh, there could be more than one solution. If it had been SAS, SSS, AAS, you name it, don't worry about it. It's automatically one solution. It's only SSA that gives us grief. Okay? So we now need to ask, this is a string? No. Yeah, string and rod. Write that down. I would strongly recommend that. And you want to say, hey, string. Is the string, what's happening with the string and the rod? What would you say here? The string is greater than the rod. And what is our conclusion when that is the case? Yeah, one solution. Done. So you made your diagram. You determine that the string is longer than the rod. And kind of imagine if this is bigger than that, it will definitely touch the ground, right? Like just think about it that way. It will touch the ground. What if it had been exactly the same? Still one solution. It's an isosceles triangle. I would like you to tell me that when you notice that. Okay, done. Next. XYZ, angle Y, side Y. Oh, I have a pair. There's a sine law and another side. So this is SSA. I'm gonna make a lot of SSAs happening here. Oh, sorry. Can I move up here? What kind of angle do I have here? Acute. Okay, that is actually the first thing. After SSA, you need to determine what is it, right? SSA, acute, it needs to look like this. And then I go through the motions, right? SSA, obtuse, so you caught one. It's gonna look like this, right? Obtuse, you caught one, and the angle that they're giving me is Y. So that I'm gonna make show up here. And the side across from it is 25 centimeters. This is 30. There's a reason. Why do you put 30 there? Why isn't it like it's XYZ? It's this way. Don't worry about it. Just make that appear where your rod is. So you go string and rod. And then you talk about those two. Okay? The string is shorter than the rod. And what's our conclusion there? No solution. No triangles are possible. And now I remembered what I wanted to tell you on that page. What if it's equal? So I will mention that. Can we just go to the to that 36? If it's less than or equal to, we don't have a solution. So even if these two are exactly the same, you do not have a solution. Think about it, it would be exactly the same length as this, right? So if it's swung, it would just touch it right there, which would match this one. It's just a line. It's not even a triangle. So if it's less than or equal to, that's what I wanted to mention there. So watch out for that. Triangle DEF, side, side, and angle. But is it SSA? F and F. Aha, it's SSA. And it's acute. It's SSA and it's acute. So I'm still fishing, didn't catch anything. Okay. Angle F is here. 75 degrees is there. Side across from it is there. And the other side, just make sure it shows up here. Bless you. And we're going to go string and rod. String rod. So let's talk about it. String and rod. String, I introduce you to rod, rod, string. Okay. What's happening here? Looking at the numbers, string is shorter than the rod. Correct? String 9.5 is less than 9.7, so we state the obvious. When that happens, you need to find the height. So we go ahead and do that. 9.7 times sine of 75. (9.7) times sine of 75. There it is. 9.2 two decimals, okay, always. And we are in miles. And now I need to branch off. There's three options here. I bring string back, and now I compare it to the height. Because I've done rod, like this happened. This is one justification here. That happened. I needed to find height to take it further. The string, if you look at 9.5 and 9.37, the string is actually greater than the height. Maybe I should do this. 9.5, because I don't want you to get thrown off by, right? It's obvious that 9.5 is bigger than the height, right? I hope so. And then here string was 9.5, and this was 9.7, right? So obviously, clearly, the string was shorter than the rod. That's why I had to find the height. And when I conclude this, how many solutions are possible once I've arrived to this conclusion? It's the very last one, right? I did less than, equal to, and greater than, so your brain remembers it's the one to the right. So two possible solutions. We will not solve them yet. That's not what we're about today. Today is just identifying how many triangles are there. I want you to try, I made a bunch of these. I'm pretty sure, at least. Yeah. We have 9 minutes, but I would like you to try 2 of them, D and E, before we go. Figure out how many triangles would there be possible based on that information. Minimum 1, ideally 2. And the chances are greater of you actually trying this on your own if you give this a try here. And I will do the answers in a bit. I will do it on this here. And just throw it on the board there. Yeah, go ahead. answer is up on the screen there. Homework. If you go to page 40, it's at the bottom of page 40. It's this stuff. Bottom of page 40 of your books. That is the stuff. It's this kind of stuff. Okay? We won't solve it tomorrow. We'll solve it on Monday. Unless. So page 40. Sorry, it's page 11 in the workbook, and the key is right next to it. Like, so if you go through the workbook, the key is there. Don't worry about solving anything just yet. I'll just make that appear here. Right, so this on page 40, that's where the homework is stated. Thank you guys, you were great. As always,